Hello, welcome to this video. My name is Marco Nuyen and I'm a trainer at Microsoft. This video is part of a series of videos about the role of a Microsoft cybersecurity architect. In this video, we will talk about security aspects of infrastructure as a service and platform as a service. Discover the essentials of securing infrastructure as a service and platform as a service environments with practical tips and insights for building robust, cyber-resilient architectures. The content of this video is mostly aligned with the area of solutions for infrastructure from a certification perspective. Now, what to consider when we are dealing with infrastructure as a service and platform as a service? That's our main question for this video. In this video, we will focus on the things we need to think of from an IaaS and PaaS perspective. When it comes to security aspects, I like to think of a shared responsibility model as a good overview of how different flavors of cloud shift the responsibilities. Things need to be done by someone, but with cloud, a lot of things are transferred to the cloud provider. From a compliance perspective, we still care and we want to know how the service provider has done it, but we talk about that in one of the other videos in this series about compliance. The main element here is that we do not need to secure everything ourselves. An important takeaway from the diagram, like we see on the presentation, is that there are things which we always need to do ourselves. Information and data security, access of devices to what needs to be accessed, managing the device itself, and accounts and identities. There will be capabilities that can help with that, but it is up to us as customers to do it. For example, mobile device management and mobile application management can help with devices, or we can leverage purview capabilities for our data, but it will not be done automatically. Same for identities. Can do with Entra, but still needs to be managed and maintained by us as a customer. Time to zoom in a little by starting with looking at infrastructure as a service. One of the key aspects of infrastructure as a service security is how to protect virtual machines, which are the main resource we use in this model. Virtual machines have many challenges, such as keeping them up to date, managing their life cycle, and preventing unauthorized access or data theft. And there is a lot of choice in types and sizes of virtual machines, all come with their own benefits and challenges. The VMs we run on Azure can be protected using platform capabilities. VMs outside are a bit more challenging, but we can use capabilities to cater for those too. Think of protecting VMs by using authentication and access controls, which allows us to define who can access and manage the VMs and what actions they can perform. We can use role-based access controls and Azure policies to enforce these rules on Azure, built into Azure and extensible elsewhere, for example by using Azure Arc as a technology. Protecting against malware, which can compromise the integrity and confidentiality of our data and applications, we can use defenders to detect and prevent malware infections of our VMs. Defender for endpoints, defender for servers, in Azure but also outside. Managing our VM updates, which ensures that our VMs have the latest security patches and bug fixes, we can use Azure Update Management and Azure Automation to automate and monitor the update process. Works in Azure, and if we can reach a VM also outside of Azure. But we may need to deploy agents, or maybe you are using another technology to drive update management. Managing our VM's security posture, which helps us to identify and remediate any vulnerabilities or misconfigurations that may expose our VMs to potential threats. Think of SCCM and CWP capabilities that we discuss in another video. Encrypting our disks, which protects our data at rest from unauthorized access or theft. We can use Azure Disk Encryption to encrypt our disks and store keys in Azure Key Vault and VM disks with encryption keys that we can control. Outside of Azure, we can also use technologies like BitLocker and DEncrypt and vaulting to get into a protected state. But there is one other thing that is very common when working with virtual machines. People want to have access, console access. Sometimes we need to use remoting when we work with virtual machines. The best way to do things on a virtual machine is to use automation. So we have scripts and command lines that can be run in a controlled way. But sometimes we need people to access the machine through a console. we need to ensure that access is secure. So I've put some options on the slide. We can use jump servers or controlled servers that people must remote into and then use them as a gateway to the virtual machines. Or if the user and the VM have direct visibility, they might be able to use a direct console. But it usually means that we must open many ports on the network, which is not ideal. So a centralizing functionality like jump servers is better. It could be a virtual server, a virtual desktop, or we could also look at Azure Bastion. Azure Bastion is like a jump server as a service. What I like about Bastion is that it connects us to verify explicitly from the zero trust perspective. First you connect to Bastion, and then we can evaluate that access request, weigh in all the evidence, and do that regularly. And only if everything is what it needs to be, then Bastion will let you connect to the VM, and it can stay in between. So the connection flows through Bastion, which can translate from a web-based session at the front also to a console session towards the VM. A note here, Bastion is for managing a VM, right? It is not intended for building an end server, an end user solution. For that, there are more suitable services in the portfolio. Now, PaaS security, platform as a service, has many different options depending on what we need to do. Right? There are different types of platform as a service. Here we see some aspects of that, but there are more choices. Right? Data can go to storage accounts or databases. Compute can be a container or function or a logic app. There are too many options to cover them all here. Right? So I just want to focus on things that are useful from our architect's perspective. We will talk about data later, but in this video, we will look at some compute aspects in a moment. Identity. Use an identity. Identity is the new perimeter. Make workloads controllable through an identity. On Azure, we can use the managed identity feature. Outside of Azure, we can use another service principal, an application identity, to give an account access to a platform as a service feature. Test ready and be ready to act. Features like Defenders can help with cloud security posture management and cloud workload protection to improve and enhance our security features. And think multi-layer, defense in depth, have firewalls at the edge before an application, protect from common attacks like distributed denial of service, and so on. If you follow the guidance in framework like the Cloud Adoption Framework and the well-architected framework, then many of these elements will be integrated. But what about compute? Compute other than we know from infrastructure as a service virtual machine. We have choices, many choices, and I personally like to use the Azure pricing calculator to see what is available. It gives me quick access and a good overview, including links to learn more, and I can instantly get some idea also about the cost of a certain component. Usually we choose the things we want from these options and then pay for them after using them, but I want to understand the pricing dynamics, and while it's more the job of another architect, I'm curious, right? Especially about what is there, what extra can we do to increase security. You can see a security submenu on my screenshot, and I want to focus on compute. We find virtual machines, containers, apps, and more. And let me simplify the compute options a little. We have physical, and then virtual, and then we have containers and serverless computing as functions. What I'm showing in the graphic is the area that we worry about as a customer on the platform. With a VM, we need to secure, update, etc. the guest OS, the middleware, and the apps, which is a lot of work. When we use containers, the responsibility moves up. We don't need to manage the hardware, operating system, and the container runtime, just the container. And with serverless compute, the focus is on the workload, not the hardware, operating system, and the middleware that is provided, securing the platform, keeping it up to date. Less tasks for us as customers to put effort into, and that's good, right? So we can focus on other tasks. But before we leave this topic, another factor. What's the risk? Can a container affect another, or can a virtual machine damage another through the layers we see here? Possibly yes. And if we have that as a risk on our risk list, we can deal with it by telling the platform that we want our workload to be isolated. It's like, hello Azure, give me dedicated hardware that only will be used by me or my organization, or put it into a network segment that I'm using. Don't expose it elsewhere. It's like isolating it. So we have a choice. Right? But as you can imagine, choice comes at a cost. The isolation will add complexity and cost to our solution. And sometimes we need to add that. Consider compliance, for example. There are compliance frameworks that demand isolation. That could result in the need for an isolated application service environment to run your functions, or a dedicated Kubernetes cluster in a private subnet to run and orchestrate your container workloads. Containers. Containers, they are everywhere. And there are challenges with that and with them. From all the compute options, this is the one we'll zoom in to more in this video, containers. Many things get containerized. It is more efficient since the operating system is stripped out, and they are very portable. Containers are very portable. With containers, there's nothing to install. The idea is that an image is created representing the compute workload. And when we need to run it, we pull the image from a library and compute it. It's smaller, it's portable, it's efficient, it's great. And look at all the places where we can go and compute our image. ACI, Azure Container Instances, Kubernetes, container apps, just to name a few. And the images we can keep in a library, like the Azure Container Registry. So, what are some security considerations? Well, save and access images from a private registry, such as the Azure Container Registry or Docker Trusted Registry. And use tools like Microsoft Defender for Cloud to check container images in a private registry and detect possible vulnerabilities. Since containers can span multiple clusters and Azure regions, secure the credentials needed for logins or API access, and only allow authorized container images and manage the flow of container images into the development environment. For security posture management, use Microsoft Defender for Cloud. It will help protect container options by comparing them to the best practices from the Microsoft Cloud Security Benchmark, the MCSB baselines. And think about using Defender for Containers as part of Defender for Cloud. That will help with cloud workload protection, a deeper scan, and behavior of your containers and container solutions. Monitor the runtime behavior of containers and identify malicious or suspicious activities, such as crypto mining, privilege escalation, or networking attacks. Make sure you collect and analyze the container logs and telemetry to get and provide visibility into the container environment and detect anomalies or indicators of compromise. Integrate with Azure Kubernetes Service, AKS, Azure Container Instances, ACI, Docker, and other container platforms to provide a unified security solution across hybrid and multi-cloud scenarios, and support automated response actions and alerts to help mitigate threats and remediate issues in real time. I had one customer that found out their images were compromised. Defender for Containers listened in and was able to understand the containers were mining Monero. Right? It's abnormal behavior. Defender for Containers was worth the investment. In general, defenders make a difference in helping us to protect, detect, and respond, but many of them need to be turned on first. That would be a gap to look for. Are there capabilities we can turn on to strengthen our security posture and increase visibility? But let's come to an end for now. In this video, we looked at considerations for infrastructure as a service and platform as a service workloads, and for platform as a service into container technologies specifically. For understanding VM remoting patterns better, the Bastion documentation can help. For capabilities that can help understand and protect workloads in general, look at the documentation that comes with Defender for Cloud. They are listed as short links on the presentation. Thank you for watching. Explore the other videos in the Cybersecurity Architect series for more. There's always more. And also, please go study, go read, and make sure to stay safe.